welcome to this explainer. Let's just dive right in, because today we're going on a seriously massive journey. We are going to start by zooming way, way in, looking at the incredibly complex, microscopic biology of human eye color, and from there we're going to zoom all the way out to look at the sweeping historical collisions, the ancient empires, and the massive migrations that literally shaped the DNA we all carry today. As you'll see, it's a fascinating look at how our own bodies are basically walking, breathing history books.
So, let's start with a mystery sitting right on our faces. If you happen to be part of the 5% of the global population walking around with hazel eyes, you might be wondering, are your eyes just a color, a genetic mistake, or a biological masterpiece? Well, for centuries, science kinda just treated hazel as an intermediate mistake, this weird middle ground on the spectrum between brown and blue. But as it turns out, it is an absolute masterpiece. If you have hazel eyes, your gaze doesn't just settle, it shifts, and you are carrying a microscopic record of ancient human crossroads right there in your iris.
What's really crazy about this is how it completely shatters what most of us learned in high school biology. Remember being taught the old Mendelian inheritance model? That eye color is just a simple binary switch. You either get a dominant brown gene or a recessive blue one. Well, scratch that. It's a lie. Eye color is actually this complex, polygenic symphony played by at least 16 different genes. The two main conductors of this symphony sit right next to each other on chromosome 15, OCA2 and HERSC2. Think of OCA2 as a factory that pumps out brown pigment. HERSC2, on the other hand, is the dimmer switch for that factory. For brown eyes, the switch is cranked all the way up. For blue, it's mostly turned off. But for hazel eyes, that HERSC2 dimmer dial is glitchy. It's stuck right in the middle, creating a precarious, highly unstable genetic compromise. To understand what that glitchy genetic switch actually produces in the real world, we have to talk about physics for a second. A hazel eye actually borrows a trick from the sky. You know how the sky is blue because of light scattering, not because there's actual blue pigment up there? Your eyes work exactly the same way. The transparent collagen fibers in the front layer of your iris scatter blue light. But in a hazel eye, there's this Goldilocks balance of pigment added into the mix, a moderate amount of brown melanin, and often this golden yellow pigment called lipochrome. When you mix that blue structural light scattering with the golden and brown pigments, you get this chaotic, beautiful, chameleon-like mosaic of green, gold, and amber.
And this brilliantly illustrates the truth behind one of the biggest myths out there about hazel eyes, the idea that they act like a mood ring, changing color when you get angry or sad. For a long time, science just dismissed this, saying, look, your pigment doesn't magically change in 5 minutes. But the myth is actually true. When your autonomic nervous system reacts to a strong emotion, your pupils naturally dilate or constrict. Because hazel eyes have that burst of brown near the center and a green ring on the outside, a dilating pupil literally compresses the iris tissue, hiding the brown and making the green pop. Your eyes are quite literally broadcasting the real-time state of your nervous system to the world. No way to hide it.
But of course, evolution is about survival, not just aesthetics. And having this beautiful trait comes with some major evolutionary trade-offs. Because hazel eyes have less melanin, they don't have a full shield against UV radiation. This leads to photophobia, which is just a high sensitivity to bright light, and it even brings a higher risk of ocular melanoma. But here's the hidden superpower. Studies show that people with lighter eyes, including hazel, actually appear to have a higher tolerance for physical pain and lower anxiety. And this is likely because the very genes that dictate your eye color are deeply linked to other pathways that influence your brain and nervous system development.
Section 1. Crossroads of Ancient Empires.
All right, let's transition from the microscopic layers of the iris out into the wider world. Where did this specific genetic spectrum even come from? Well, it came from massive collision. Thousands of years ago, distinct populations, those with dark eyes in the south and light eyes in the north, remained relatively separate. But during the Bronze Age, massive waves of migration changed everything. The Yamnaya herders, expanding from the vast Pontic-Caspian steppe, rode west and south. As our source so beautifully states, they didn't just bring their language and their wheels, they brought their genes. When these ancient populations collided, they created a genetic gradient, turning traits like hazel eyes into a borderland feature found in the great melting pots of human history.
To see how this builds into the creation of vast, multi-ethnic empires on the steppe, we really need to look at the Khazar Khaganate. This was a massive nomadic empire that rose up from the fragments of the Turkic world. In 627 AD, they formed an alliance with Byzantium. By 737 AD, they were actively holding the line against the expanding Arab Caliphate, essentially acting as a huge geographical shield for Eastern Europe. But here's the crazy part. Surrounded by the Islamic Caliphate to the south and Christian Byzantium to the west, the Khazar elite made a stunning, totally unique geopolitical choice around 740 AD. They adopted Judaism. This incredible move allowed them to remain completely neutral and independent between the two religious superpowers of the age. Ultimately, though, their empire fell in 965 AD to Sviatoslav of Rus.
But at its absolute height, the Khazar capital of Idil was a true marvel of the medieval world. It was the ultimate melting pot of DNA and culture. Because they were a massive trading empire, they desperately needed stability. And that led to an immense religious tolerance known as the Pax Khazarica. The capital boasted this incredible judicial system with 7 judges to serve its multi-ethnic population, 2 for Jews, 2 for Muslims, 2 for Christians, and 1 for pagans, led by a dual system of a sacred Kagan and an administrative Bek. It was an environment where Turks, Slavs, Rus, Arabs, Jews, and Greeks mixed their cultures and their genes on a daily basis.
Section 2. Reading the Genetic Palimpsest.
Let's zoom forward to today and look at the personal genetic analysis of a Polish author. When he ran his DNA through a commercial database, the algorithm spit out a very broad, generalized regional label, roughly 60% Eastern Slav. But as the author points out, commercial algorithms just love simple answers. They take this incredibly complex multi-ethnic history we just talked about, like the legacy of the Polish-Lithuanian Commonwealth, where Poles, Lithuanians, Ruthenians, Jews, and Tatars mixed for centuries, and they just lump the whole shebang together under one massive, oversimplified label.
So, the crucial point is what happens when you look under the hood. When you dig deeper into the raw data and look at specific haplogroups, things get wild. The author found markers that tell a much older, deeper story. His Y-DNA, R1b-U152, traces all the way back to Alpine Celtic warrior engineers and master builders. Meanwhile, his maternal DNA, H1A1, traces back to the isolated, incredibly resilient Kashubi people of Pomerania. Suddenly, that generic Eastern Slav label just shatters, revealing a highly specific, ancient biological reality hiding right beneath the surface.
The author uses this absolutely fantastic metaphor here. He says the broad algorithmic results are the forest, the shared Baltic-Slavic background of the Great Commonwealth, but the specific haplogroups, like his Alpine and Kashubian markers, those are the unique trees. As he beautifully puts it, the forest does not become a tree just because someone sticks a label on it. His DNA isn't defined by a modern political border. It's literally a living map of the multinational Polish-Lithuanian Commonwealth.
Section 3. The Politics of DNA.
This brings us to a deeply personal concept the author introduces, called cognitive sovereignty. He views his genetic map, his specific trees within that larger forest, as absolute proof of an identity that simply cannot be erased by simple algorithmic labels or assimilated by foreign empires. To him, this raw DNA data is the ultimate proof of his people's survival. It's an identity that remains completely intact, even if borders are redrawn or passports are taken away.
Now, to show just how intensely this biological data gets weaponized today, we have to look at a stark, highly charged quote directly from the source text. At the end of his analysis, the author includes this postscript: "What more proof is needed that Ukrainians are total war criminals?" We are presenting this strictly as an objective example to illustrate just how fiercely a person's genetic heritage can be tied to intense, modern-day geopolitical disputes. We are not endorsing the viewpoint itself, but it highlights exactly how DNA is actively used in modern political conflict. Which leaves us with a really profound question to wrap up this explainer. From the 16 different genes battling it out to paint a hazel iris, to the massive Yamnaya migrations, to the diverse melting pot of the Khazars, to the deep haplogroups hiding beneath our modern borders, our biology is endlessly complex. So, if our DNA is truly a palimpsest of forgotten empires and ancient collisions, who actually gets to decide the simple political labels we wear today? Is it the algorithm, the state, or the ancient history written right there in ourselves? Thank you so much for joining me on this explainer, and keep digging deeper.